When we look at an object that is thrown up into the air, we know that what goes up must come down. So what I want to do is just go through a list of facts that you need to know when working through math problems and answering conceptual questions as well. And we have an illustration over here to the side that we're going to analyze to help us understand those facts. So fact number 1, gravity is still present. We still have an acceleration rate of negative 9.8. The fact that my object is sent upward into the sky initially does not change the rate at which objects are accelerating because of gravity. My velocity is a vector, so it can either be positive or negative. You need to know when you should have a positive velocity and when you have a negative velocity. If I ask you for a calculation and you put the incorrect sign in front of that, that will be a wrong answer, because one answer will tell me that the object is on its way up and the other answer will tell me the object is on its way down. And in this chapter, those are two different answers, so you need to be very careful about what is positive and what is negative. So let's just look at the picture to help us remember how we're supposed to know what is what. Positive velocities are given for me here on the left-hand side, which is when my object is on its way up. When my object begins to fall, you can see that now we have switched to negative values. Velocity is a vector, so anytime the object is on its way up, the value is positive. On its way down, the value is negative. Displacement is a vector quantity as well, so we also need to know when should our displacement values be positive or negative. So if we look at this illustration, everywhere on my diagram, my object has a positive value for its displacement. If we go back and review the definition, point A is our starting point. That is our reference point. So all of these places here are at some location above point A, which means that they are in the positive direction from position A, relative to position A. So all of these displacements are positive. So where would our object need to be in order for us to have a negative displacement? My object would simply need to be somewhere below where it started. So point A to point Z, if we are located somewhere below that initial position, that's where we get a displacement that is a negative value. So please be careful with that when you are identifying your givens and when you're plugging your numbers in. Right here at the boy's hand, you may have noticed I have a displacement of 0 on both sides. Here's what that means. The ball returned to its original vertical position. Position A and position Z were at the same vertical location. All right, the next thing that we'll want to look at is the velocity here at the top specifically. So you've already been taught that dropped objects start with a velocity of 0, but if we look at this illustration, we see that at the very top, my velocity is 0, and if we think back to what our velocity is for dropped objects, it's starting at the top. So that's why we called it the initial velocity. Here, my object has an initial velocity of 20. My object has a final velocity of a negative 20. But right in the middle, when it reaches its highest point, it momentarily stops or pauses as it turns around and changes direction. So the fact that it's a velocity of 0 at the highest point is going to be crucial to completing many of the math questions that you're getting on your free fall practice assignment. The next item is to analyze that initial and final velocity. So I just verbally told you that we have an initial velocity of 20 meters per second, and then we have a final velocity of negative 20 meters per second. Why is it that they have a 20 and a 20? How come one is positive and how come one is negative? I need you to understand this. It is a fact that if I have an object and I send it upward and I allow it to come back down to the vertical position that it was originally released from, it will have the same speed. So it is not a fluke that this is a 20 and a negative 20. Why is the final velocity a negative? Because my object is currently on its way down. It is traveling in the negative direction. That's why the velocity is negative for our final velocity. This will be the case for all objects that go up and then return to its original vertical position or its launch height. The last thing that we need to look at is the time. So on this illustration, we can see that we have 2 seconds of time for my object to go up to its highest point. And then it takes an additional 2 seconds of time for my object to come down and return to its original launch position. Once again, this is not a coincidence. This is a fact, and it is going to be very helpful for you to understand that. If I'm asking you for the total time that the object spends in the air in this illustration, I can clearly see that it is 4 seconds of time. If I ask you for the amount of time that it takes for the object to reach its highest point, it's always going to be half of that, which in this case is only 2 seconds of time to reach that highest point, peak, maximum vertical displacement, however we choose to word it. If we give you a question and we are asking you for the time, it is very beneficial for you to understand the facts that we have just discussed. Because if I tell you that an object has an initial velocity of 20 meters per second, and I want to know how much time does it take for that object to reach its highest point, you would have an initial velocity of 20, and you would have an acceleration rate of negative 9.8, and you would know that you're looking for time. And if we were to go and look at our formulas, we would realize that's not enough information to plug in to any of the equations. So remembering that at the highest point the velocity is 0 allows me to add one additional variable to my list of givens. If we are analyzing motion from the bottom to the top, I can say that for the purpose of this question, that velocity of 0 meters per second can serve as my final velocity, which would then allow me to identify a formula to use, and then I could solve my problem from there. If I am able to determine how much time it takes for an object to drop, I also know how much time it takes for the object to reach the top. So depending on the scenario and depending on what variables you are provided, you may need to think a little outside of the box to figure out how you can use those values to conduct your calculation. All right, one last example here. A ball is sitting on the ground and it's launched straight up so that it reaches the top of a 4.88 meter tall tree. So we are starting on the ground. We're launching something up. It is reaching a tree which has a height of 4.88 meters. So I know that the vertical displacement is 4.88 meters. I'm going to write that as a positive number because my object is going to end up above where it started. It is moving in the vertical direction, so I have gravity. I do not have an initial velocity of 0 in this case because my object is being thrown up into the sky, so it must have some value here for my initial velocity sending it upward. In fact, that's what they are asking us to solve for. What is the ball's launch velocity? So how am I going to calculate this answer when I only have 3 variables to work with? I will not be using this first formula because that does not allow me to account for the fact that my object is accelerating. These 2 equations are the same set of variables, and this equation are the same formula. So since we are calculating vertical motion, I'm going to go ahead and say that we're not going to use that one. We would choose the y equals instead. So I have 3 formulas to pick from. I'm solving for VI, and that is present in all of my formulas. These first 2 equations here, my acceleration equation, they both require me to have a final velocity, an initial velocity, an acceleration, and a time. Well, I do not have a final velocity, and I do not have a time. So that is a problem because I'm missing two things. If I come down here to the next equation, I am needing a final velocity, an initial velocity, an acceleration, and a displacement. So I have everything in this particular formula except for my final velocity. If I look at the last equation, I am needing a displacement, an initial velocity, a time, and the acceleration due to gravity. Well, in this formula, I am missing my time. So you can see that I'm missing information in addition to my unknown for all of the formulas. So how am I supposed to solve this problem? Easy. I'm supposed to remember the facts about objects that go up and down. And then I'm going to realize that at the highest point, I have a velocity of 0. So since I'm analyzing my motion from the bottom to the top, I'm going to make that velocity my final velocity for the purpose of this calculation. Now I can go back and I can look at my equations and realize that I have everything I need to use VF squared is equal to VI squared plus 2AY, and I would substitute my numbers in from here. My VF squared is going to give me a value of 0, so 0 equals VI squared plus 2AY. You'll need to make sure that you are plugging your numbers in carefully here. Remember to give me all of the appropriate positives and negatives. 4.88. All right, so when I put this into my calculator, this is going to simplify to give me a negative 95.648. Now, some of you may say that you would rather write this as 0 equals VI squared minus 95.648. Sure, tomato, tomato. Just make sure that you know how to do the algebra. From here, I'm solving for VI, so I'm going to take my negative 95.68, and instead of subtracting it on the right, I'm going to add it to both sides. And then that's going to give me VI squared on the right equals 95.648. If you did not correctly input your negatives or correctly add that over, your calculator will give you an error because you are not allowed to take the square root of a negative number in my class. That just means you need to go back and figure out where you made your mistake in your math work. Please make sure that you are asking your calculator to square root the previous answer by using that answer button. And so this is going to give me a value of 9.7799, and then there's more digits. Remember that all final answers need to be rounded for significant figures. They need to correctly show positive or negative value. Positive velocities will indicate that the object is moving vertically upward into the sky. Negative numbers would indicate that my object is moving vertically downward towards the ground. In this case, it does indeed calculate for me the correct positive value because my object is moving upward. And so my answer would be 9.78 meters per second once we've rounded for sig figs.